Alright, so looking at the JavaScript Runtime Environment here. So what we've got here is a list of different components that make up the JavaScript Runtime Environment. And a good question would be still, what is a JavaScript Runtime Environment? So thinking of it like this, Chrome has a JavaScript Runtime Environment. Node is a JavaScript Runtime Environment. There's also some confusion. I'm going to say JRE from now on because I don't want to keep saying JavaScript Runtime Environment. So there is some confusion between the JRE and the JavaScript Engine. And I think maybe if I explain that, it would clear up the definition of both. So the JavaScript Engine is responsible for executing the JavaScript code, preparing it for execution and actually executing it. But if that was all there was, JavaScript wouldn't be very useful. So the engine being concerned with just the execution, but when you're using a browser, you're not just executing code, are you? There's lots of other stuff going on. You're trying to deal with events, people are clicking on buttons. You want that to be communicated to the code. You want things to happen. If it was just the JavaScript engine, that couldn't happen. So I would describe the JavaScript runtime environment as a kind of everything you need for JavaScript to be useful. And the JavaScript engine is just executing JavaScript code. I mean, I say just executing code. It's pretty complicated, and hopefully we can have a look at that in a later video, sorts of abstract syntax trees, etc., but it's not worth diving into for now. Yeah, so these are the parts that we're going to have an overview of. The JavaScript engine, which is comprised of a call stack and a memory heap, or I should say these are two important structures within it. And also on the JRE side, we've got queue, event loop, and other APIs, which we're also going to have a look at. Alright, so we're going to look at the JavaScript engine now. Yeah, I say the JavaScript engine, but I should say a JavaScript engine, because it's one of many. So V8 is probably the most popular JavaScript engine that exists. It's used in Chrome, Microsoft Edge, Opera, on the browser side, and Node as well. Node also uses V8. So that's one of the popular ones. Firefox uses SpiderMonkey, and I read the other day there's a JavaScript engine in the James Webb Telescope. So there you go. There's a lot of engines around. So I think there's going to be implementation differences, the way they optimize stuff, etc. But for what we're talking about today, having a look at the heap, things like that, I think we're all good. It doesn't really matter which one we use. So we're going to use Chrome anyway. So the first thing we're going to do is have a look at the heap, and the heap is just like an unstructured area of memory, I would say, for JavaScript. It's not like the heap data structure. This is just a messy heap of data that JavaScript's like chucking variables on and stuff, just storing things. But yeah, it's cool. We can actually have a look at it in the browser. So what we're going to do so that we can see it is we're going to make an array. You can see in this code here, called it gnarly array, because I'm old. I think gnarly is a cool word. We've got a little event listener here, so when someone clicks the button, we are going to call this constructor function, and it's going to return us an object. Right, so this is the code that we just looked at with my sweet button. Let's get the debugger. Cool, so to take a snapshot of the heap, we can go to the memory tab and select, heap snapshot. Alright, let's do it. Alright, so there's a lot of things in there. As I said, it's a messy heap. and looks like mainly sorted by constructor function. So I guess you know what made it. Now let's have a look at the heap after we create a new object. So we've created a new object. We're going to take a new heap snapshot. So we've got a problem here, right? We've got loads of stuff on the heap. So how can we find what I made? Well, there's a little cool trick that I learnt. So you can compare between the two snapshots. And there is some other stuff there. But luckily, because, so this is why I didn't just like make a new string or something like that. Even though some other stuff had changed on the heap between the two snapshots, we can easy to see on heap because of the constructor function, if you see what I mean, because it's in that column, it's sorted by constructor function. Well, not sorted, but you know what I mean, identified. So anyway, we can see that that object was made, it exists on the heap, and that's the property, yeah, boolean true. So I mean, I'm no heap expert, but we've proved that it exists. That's where some of the variables go to live. Cool. So now that we know the heap is real, not just a wild dream, let's have a look at the call stack. Alright, so now we're going to have a look at the call stack. We're going to comment out the code from the heap example, and we're going to uncomment this new call stack code. Yeah, so if we think of the heap as somewhere that when the JavaScript engine is just kind of processing through the lines, is storing variables, things like that on the heap, then the call stack would be where functions are executed. The JavaScript engine's going along, and once it finds these function calls, it puts them on the call stack, but we'll have a look at that in a second. So what we've got here is just some very, very simple code. We've got function A being called from the global scope. It should hop in there, call B from inside A. We should get console log function B, then that's finished, goes back to A, that's finished, goes back to the global scope C, and we're going to console log C. So I would expect function ABC to get console logs. It'll be exciting, won't it? And yeah, it's already there. I can refresh just to prove. Oh dear, what's going on with the debugger? Anyway, ABC. So that's probably not taught you much. So let's hop in to this code, and now you know, these are supposed to be tutorial videos, but I don't want to be patronizing. Like, and everyone's thinking like, what? I already know this, but I've got to cover all the parts, and you probably know the call stack, because if you've had an error, you've done debugging, you've seen it. But let's you know, indulge me. Let me feel clever. So we'll put some breakpoints on there. Okay. The eagle-eyed observers among you might have noticed that I've just jumped to the top of the screen. That was because I was actually hiding the call stack with my face, which wasn't ideal. You know, I don't dislike my face, but the call stack, more important at this time. So the call stack is here. We haven't entered a function yet. We're just in the global scope. So it just says anonymous. That's like window, global, kind of the lack of being in a function. So you can think of that as kind of an empty call stack. Just the main one, like that's always going to be there as long as the JavaScript's running. Okay, so let's jump on. Cool. We've gone into function A, and you can see there it's been put on the top of the call stack. So this global scope is underneath it, and now A has been put on top. Last in, first out. Now we're going to carry on. It sees B inside A. That's an important bit. So now B is on the top of the call stack. So kind of the only really important thing to remember about the call stack is that you can't take stuff out the middle. You know, it's like a stack, like most nice people would do. You just take things from the top of the stack. You don't chuck things. You don't drag things out the middle or from the bottom. And JavaScript is nice, so it takes from the top. So yeah, because B has been called from inside A, so the function A is still running, it's still on the stack. Then B is put on top of it, and we won't be able to exit A until B is finished. So it's like run to completion. It has to finish, then B can get popped off, as we'll see now. Boop, popped off the stack, nice. Now we can exit A. That's gone, and we're back on the global. C, not really sure why I added C, just as another demonstration, just that we're back to the main thread. You go back in C, that's now on the stack. And then, yeah, that's it. So you saw the things getting stacked. Great. What should we look at next then? Just looked at the heap and the call stack. Very important bits of the JavaScript engine. Now, this course might be free, I might be an amateur, but I put the hours in, you know, I made some slides. You know, they're not high quality, but here we go. So we've got the JavaScript engine represented by this blue box, and we've got the things that we just looked at, the memory heap, the call stack. So this is where things get a little bit more interesting, because yeah, I suspect that you probably knew most of what we've talked about so far just through using JavaScript. You know, if you've been developing, debugging, you'd come across these things. But yeah, this should hopefully be a bit more interesting. So thinking about it, JavaScript is called a synchronous single-threaded language, and single-threaded means it has one call stack, and that means that it can only do one thing at a time. It's not multi-threaded, but there is this kind of notion of concurrency. They say the concurrency model for JavaScript. What does that mean? Well, we looked at the call stack, right? Last in, first out. It's chucking functions on top of the call stack. They've got to finish before it can go back down. So that kind of, you know, raises the question. You're on a website, you do something, you know, you make an AJAX request, you click a button, some notifications open. That's a function, right? That's going on top of the call stack. But does everything freeze when you do that? Does everything freeze up? You can't use the browser anymore, because if JavaScript was just the JavaScript engine and the call stack and the memory heap, you'd be stuck, right? Because until that function had finished, say, you know, open notifications, then it would be stuck. There's nothing else would be able to happen at that time. So yeah, why doesn't it work like that? Why can we kind of do something and then just carry on? Why is there concurrency in JavaScript? And now this is what we will look at next. To understand why JavaScript is able to do some things concurrently, it helps to have a look at like the situations where it can't do things at the same time. So what we've got here is what we would call blocking code. It gets in the way of JavaScript dealing with anything else that might come in. I'll show you what I mean. So we've got a console log before and after the loop. We've got a loop up to a silly number, nothing else going on in there. This is all in function A, and function A fires when we click the button. So let's have a go on that. We're going to click the button. Now what's kind of interesting, might be kind of hard to see, but you can see that the button doesn't kind of reset to its clickable state. Once you've clicked it, it stays depressed, and then once the loop is finished, it kind of pops back up. And that's, that's kind of showing that you can't deal with the events at the moment. So if I click it 3 times, you can see from the console log, they're not being fired off straight one after the other. It's doing them sequentially, right? It can't handle it. So, well, let's have a look at the code to see a bit more what I mean. So we'll put a console log in here, and we'll click the button. We'll do a few iterations of the loop. So what's I now? So I's up to 4. I can see on the call stack here, we've got the global scope again, and now it is in function A. So this is happening, this function A at the top of the call stack. So as we learned a bit ago, nothing else can come in at the moment, unless we kind of stack another function on top that it goes into to do something else, like if there was one inside the loop. Nothing else can come in, so it's essentially blocked, right? It can't handle the click event when I'm clicking the button, and it has to wait till everything else is done. Okay, so we'll comment out this blocking code and show some non-blocking code. Save. Take that breakpoint off. Okay, so that's this is probably not news to you. Let's just go back to the code quickly. So we're setting this timeout here to fire after a minimum delay of a second, and we're doing console log just immediately after the set timeout is set up. So the thing about this is you can see that we're going straight to the next line of code. It's not waiting a second before we execute this next line of code, this console log. It's not blocking the thread, it can carry on. So where is set timeout going? is the best question I can ask. So if we have a look here, we'll look at these breakpoints. So I'm going to click. Alright, so after the set timeout function has been called, we are doing this console log, and you can see we're in the call stack. It's in function A, makes sense. Set timeout, let's carry on. Now inside that, the callback that's inside set timeout, that is anonymous, so global scope. And this is why it's not blocking. It's being executed, this callback, but from the time the set timeout was kind of set up, it wasn't blocking thread. It wasn't waiting a second on our main JavaScript thread, because if it was, you'd have a second of not being able to do anything. So that means it's been sent off somewhere, right? Kind of an async function. And the thing is, it's not part of JavaScript. No way, it's not part of the JavaScript engine. So it's part of the JavaScript Runtime Environment. That means that you're just sending that off to a web API. I did not realize set timeout was a web API, and there's a few others that may be a surprise, maybe not, like I think the obvious ones are like fetch and Ajax. You kind of know that because you're sending a request and you feel like that would be handled somewhere else. But kind of sneaky ones like maybe the DOM, set timeout, they are actually also APIs. So that might make things a little bit more clear. So it's not being processed on JavaScript single thread. It's been sent off somewhere else. That's doing the work. I suppose the next question is, how does it come back? How does that, because as we saw, the inside of the set timeout is being executed on the global scope, so it's not inside function A anymore. yeah, how did it get there? How has it come back from this web API? And that's what we'll have a look at next. Alright, so we already knew about the JavaScript engine, and we just touched on web APIs, and the outstanding question is, if something like set timeout is a web API, and that callback's being sent to it, what happens when the web API is ready to send something back? So yeah, so here we've got set timeout with a callback, delay of 3 seconds. Once that 3 seconds has passed, the web API will then return it to the queue. Now there's quite a few names, and there's also like more than one queue, but that's irrelevant for this this little overview now. So I'm just going to call it the queue. Yeah, there's quite a few names if you have a look around, but we'll just call it the queue for now. So the callback is being put onto the queue, and it's saying, hey, can we execute this as soon as the JavaScript engine has a chance? Now, when does it have a chance? This is, you know, the main, or maybe the solidifying part of everything, the event loop. So we've got callback A waiting on the queue, waiting to be executed. When will that happen? The event loop will only add things onto the call stack when the call stack is already empty. So yeah, that's kind of the main takeaway. If you are trying to execute callback A, you got some other things on the call stack. Say that like the for loop we were looking at earlier, that's running. You're not going to be able to run this callback, so it would be blocked. As soon as the call stack is empty, then the event loop chucks the callback on the call stack, and it gets executed. Alright, so what we're going to look at now is a little bit of evidence, a little bit of proof that the event loop works the way that I said it did. Alright, so we're going to go wild, and we're going to uncomment all this code from the last example, and I'm going to change this set timeout to 1 millisecond, just so it's obvious, like the results of this code. And I'm going to save it, because I always forget to do that. Alright, so let's have a little recap on what this code is going to do. So when I click the button, it's going to call function A. Function A is going to say, hey, set timeout. So it's going to call a web API with set timeout. And that web API is going to say, hey, I'm going to execute this console log after 1 millisecond. And when it's ready to do that, it's going to put that on the queue. It's going to put this callback here on the queue. And then our kind of JavaScript engine side code is going to carry on whilst the web API is sorting out the set timeout, and it's going to go to this for loop, which, as we looked at earlier, should be blocking. Alright, so let's have a look at the code. Alright, I'm going to click the button. Ready? Let's do it. Oh, okay. Alright, so after setting timeout, so that was just after we set the timeout. This is before the loop, after the loop, and a true statement, but a confusing one. So, you know, it says I'm going to fire after a delay of at least 1 millisecond, which it did. It was just quite a lot longer than that. What happened, as you know, I suppose we just talked about it really, but the web API was ready after a millisecond. It did it, and it passed it back and put it on the queue. The event loop took a look at the call stack and said, hey, is it empty? No, it wasn't, because that for loop was blocking the call stack. It was processing, so function A was still on the call stack. The callback that the set timeout had set up couldn't get in, so it had to wait until the for loop had finished and function A had executed. Then it executed as soon as possible. Yeah, so that's cool. That means that the event loop model is true. You do have to have an empty call stack to be able to process messages from the queue. Alright, so coming back to this diagram, hopefully you feel like you know a little bit about each of these components, each of these parts of the JavaScript runtime environment. And yeah, I genuinely hope you did learn a little something. If you didn't, I'm sorry. I'm genuinely sorry, but this is like quite a light overview of each of these parts. So I've skipped over details on a lot of things, but this is about getting the general overview, and I think hopefully it did that purpose. If you don't find me too irritating, hopefully you'll stick with me for some more videos, and we will look at each of these bits in more detail. Yeah, and just try and they like to call it deep dives, right? Deep dive. We can deep dive into each of these things and find out everything there is to find out. And yeah, I know this hasn't been the most professional production, but I've genuinely enjoyed making this one, and thank you very, very much for watching. Until next time, thank you.